Hello, my name is Carlos López. I'm going to speak about data validation. First of all, I want to speak about this scheme. This scheme have different parts and different levels. I'm going to start speaking about ones. This part consists input some logic thresholds on the raw data. For example, imagine that we have one thermometer, that thermometer is in the middle of Barcelona, and that thermometer is giving to us the temperatures from the Barcelona, and one of the dates says that the temperature of Barcelona is 1000 degrees. We know that that value is wrong, and then we have to discard that value. The way that these parts have to do is like this. We know more or less that the values are going to be like this. We know that if we find one value that says that the temperature is 1000 degrees, for sure is wrong. Then this part consists input one logic threshold. For example, we know that the temperature will never be above 50 degrees. And we know that the temperature will never be below less 20 degrees. And then if we have one value that is outside of these thresholds, for example this, we have to discard. We just have to take into account the values that there are between these thresholds. Now I'm going to speak about this part, trend. Trend, this part consists in detect sudden changes in the system. For example, in the same example than before, the thermometer in the middle of Barcelona, we have one graphic that is saying this. Here we have the temperature and here we have the time. Imagine that the temperature is going with one line like this, and suddenly we have changes. We know that these values are wrong. Could be fault of the electrode of the sensors, or could be fault of the noise in the system, but in fact is wrong. Then this part have to detect these sudden changes and discard that values and don't take into account. Okay, now we are going to speak about time series models. This part consists in just information that we have obtained that time before and determine if the electrode of the sensor is correct or not. For example, imagine that we have one building when we are controlling the flow of the water. For example, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. We know the consume on Monday is more like this, the night is less. Tuesday, Wednesday, in that building have one party every Wednesday in the swimming pool, and then the consumer flow is higher than the other days, more like this. Okay, in the weekend there are less consume, or maybe a little bit more. We have the model of this week, and then we can use that information that we know for determining if the electrode of the sensor is correct. For example, if the sensor is saying this, we know that could be right. But if the sensor is giving this, we know that is wrong. And then we can detect that there are one failure in the system. MATLAB have one tool called IDEM that can help us to use this part. And sometimes could say us that it's better prevent what will happen the next Monday from the last Monday than not prevent that yesterday and before yesterday. If we detect a failure, we have to do reconstruction. Okay, now I'm going to speak about septial model. In this part, we can detect if we have one failure in the system, but we can determine where is exactly. For example, imagine that we have one system of pipes. This is pipe 1, pipe 2, pipe 3, pipe 4, pipe 6. And the water is flowing in this direction. We know that the flow of pipe 1 more 2 more 3 is the same that flow that should be in the pipes 4 and 5. If we have this is bigger than pipes 4 and 5, we know that this system has one fault, but we don't know where is exactly. We know that could be for one link or for lecture of the sensor, but we know that we have one fault, but we don't know where is exactly that fault.